Hmm. So okay. So print tree. So mission print print given tree to the console. Okay, so example. Okay. On the left side, we have a tree, and on the right side of this table, I will write the ASCII representation of the tree. Okay, so when a tree consists of only one element, we will just print out the value of the node. Okay, this is the trivial case. And Let's add some more examples. When issue when a tree is of height 2 and the root node has 3 children like this, what we want to print out, it looks like this. So first we'll have the root node on the leftmost position, and then we will print the children like this. So the first child will be printed on the same line as the parent node. And the second children, the second child will be printed like this, and the third child will be printed like this. Okay. Okay, let's move on. So so until now, the program seems very simple, but we can add more complexity to the problem. So, for example, what if we have a tree of height 2, like this, okay? 5, 6, 7. All right. So what is the expected answer to this input? It's gonna be like this. So the root node doesn't change, the first node doesn't change, but the second node has its children. Okay, so we want to print the children of number 3. They are 5, 6, and 7. Okay, and then the last child of the level 1. Okay, then what is the more complex example? The more complex scenario is this. Again, we are given a tree of height 3, but the length of the value of a node is different from each other. For example, what if the first child of the level 1 has a value of 200, okay? We should print out something like this, but don't you think it's too what is it? Unsightly? Yeah. So in this case, we want to enlong the edge according to the length of the longest child in the level. What I mean is that we should enlong this node by 2. Here. This is much clearer than the first try, right? Okay. So I think these are the good examples to start with. Let's think about how to proceed in solving this problem. Okay, so I want to let's see. So what I am thinking is that outputting line by line. For example, we won't construct a string or output column by column, like one here. So we draw this part, and then we will draw this consecutive pipes, and then we draw these numbers in sequence. No, we won't do that. We will write line by line, like we will construct the string for this line, and next this line, next this line, and print out at the end of the program. So we, as I told, we don't have to print out immediately. I mean, we can have an array which will hold the strings, each representing each horizontal line. Okay, so let's think about how to create that array first, and so that we can focus more on the data structure than the whole part of the program. Okay, so let's see, ASCII representation of the tree here. Okay. And what we're gonna do is, yeah, Yes, so from now on, we will think about what shape of data structure work, works fine for our needs. Okay, so to print out a tree of single element, we don't need a complex data structure. So maybe as an array of single element works fine. Okay, so what if the tree has some children? Okay, so we need to store the data level by level. So on the we store data something like this. Okay, this way we can know that the maybe we should define a more detailed data structure. So like this. So yep, the root node's value is 1 and the children are 2, 3, 4. Okay. This is enough if we are going to write or print out a tree of this data structure. I mean, all the nodes have the same length of value, and the level of the tree is 1. We just need this data structure. That's enough. Okay. Next, what about this case? We need a more complex data structure to be able to print out the tree out of the data. So let's think about it. Okay, so first, v is 1, and maybe I should save the space. Okay, and children. Okay. Each child is also a node. So a node is represented by this structure, and children. V3 V5 children. Da 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 6 and 7. Let's make some space, or like here. Bye bye. All right. Okay. The subtree of node 3 has been completed, and the node 1 also has a child node of value 4, which doesn't have any children. Okay, something like this. So given this data structure, we can draw this tree. Okay. First, although it's very complicated at this stage, for example, the algorithm of printing out this tree from this data structure is, okay, I will explain it around here. Bye bye. All right, so the algorithm okay. So let's see. Check if X node. Check if node check if node if node has at least one child. Blah blah blah. Else if the node doesn't have a child, let's see. Okay, so let's suppose we are given this data structure and we call it the node, okay? And if the node doesn't have a child, we should just return node.v, right? And if node has at least one child, what we need is well, I'm one child. Let's see. It's gonna be like this node v b node dot